get down to the class, I'm sure you've been enjoying my class so far. Without wasting our time, by the end of this class, you as a student are expected to be able to define what oxidation is and what reduction is. Okay, you should be able to state the definition of both oxidation and reduction. Okay, by the end of the class, also you should be able to identify reactants that may be identified as oxidizing agents, that is the one that is being reduced, and the one that will also be identified as reducing agent, that is the one that is being oxidized. Okay, good. So let's get down to class. Of course, the process of roasting, okay, of metals talks about when oxygen in air react with an ion. Okay, so the effect is known as rust. Okay, and that process is rusting. That means the oxygen, okay, reacting with iron. Okay, and we know that rusting is a chemical change, isn't it? Yes, and in a chemical chain, new substances are formed. Okay, good. So, a pictorial example where we have some metals that become rust as a result of oxygen reacting with the ion. Are we together? Good. Then, in oxidation reduction reactions, okay, this reaction provides us with energy from food. Okay, so energy from food is made utilized by oxidation and reduction reaction. So we utilize the energy from the food substances we take in via this oxidation and reduction reaction. That means there will be transference. Okay, good. Then we talk about electrical energies in batteries. Of course, they also utilize oxidation and reduction reactions. Okay, good. And remember, we talked about electrolysis in the previous class, where we talked about elements or substances being liberated, discharged at the electrode, right? Good. At the electrode, either cathode or anode, there will be reactions there. So, and that reaction is purely either oxidation or reduction. Are we together? Good. And that is important in battery technology. Also, oxidation reactions occurs when ion rust. Okay, there will be gains of electrons and there will be loss of electrons. Okay, or transfers of electrons. So, primarily, what we must understand is that in an oxidation reduction reaction, electrons are transferred from one substance to another. Okay, I like you to digest this very important statement. Okay, in an oxidation reduction reaction, electrons are transferred from one substance to another. I've heard my student asking me, sir, is it possible, can oxidation occur on its own? And I said no. Okay, the both oxidation reductions will always occur simultaneously. Okay, when there is loss of electrons, then there must be an acceptance of electron, or there must be gain of electron. Okay, so that is why we will always talk about the two of them. Okay, that's simultaneously. Are we together? Good. So let's have a clear example from this picture before you now. So you can see that because we are saying that electrons are transferred, okay, from one substance to another. So we are going to consider, let's pick our pen so that it can be a bit clearer. So we have substance A and substance B from the left hand side, okay, the left hand side of our equation, and that is the right hand side of okay, good. So from the right hand side, left hand side now, that is the reactant. Of course, the right hand side the product. So electrons are being transferred from substance A to B, okay, and the process by which as electron is transferred from A, that means there is loss of electrons. Are we together? And that's why you can see we have something like this. So A has successfully donated an electron to B. So loss of electron is known as oxidation. Are we together? So the process is what? The process by which an electron is transferred from one substance to another, by which electron is donated, that is known as oxidation. Okay. Now, which of the substance accept or gain electron? As you can see, transfer from A to B. So B has accepted an electron. So that is why you can see from here like this. Okay. So there is what? An acceptance of electron. So B has gained an electron and A has what? Loss. There's loss of electron. Are we together? So because B has gained an electron, okay, we say the process of gaining that electron is known as reduction. Are we together? So you can see now for a clearer view and understanding. So oxidation, okay, is loss of electrons. So oxidation, loss of what? Electrons. And that's why we say is oil, okay, for a simple understanding. Then reduction is what? Gains of electron. So B gain an electron and the process is known as reduction. And that is what? Rig. Are we together? That is what? Rig. So you should be able to explain to anyone, okay, including yourselves. So let's move on to the next agenda we have. So we are going to be able to explain what an oxidation and reduction is based on 4 components, okay. So and the components are, number 1, I'm going to tell you the definition of oxidation and reduction in terms of oxygen, in terms of hydrogen, number 3 in terms of electron, okay, and in terms of oxidation numbers. Are we together? So you follow the class attentively. So let's bring about reduction also, so that we can see both sides. So what is oxidation as far as oxygen is concerned? So now when oxygen is added to a substance, that is oxidation. Are we together? And when there is a removal of oxygen from any substance, that is reduction. So it's more or less like opposite. Addition of oxygen is what? Oxidation. Removal of oxygen is what? Reduction. Are we together? Now in terms of hydrogen, so when we add hydrogen, that is reduction. So addition of hydrogen is what? Reduction. And removal, that is the opposite once again. Removal of hydrogen is also known as what? Oxidation. You can see that is very clear. Then we move to in terms of electron. So previously I told us that oil, that means oxidation is loss of electron, and then reduction is what? Gains of electrons. So that is that. So in terms of oxidation number, okay, in terms of oxidation number, we can see that oxidation in oxidation reactions, there will be what? Increase in oxidation number. Of course, what is an oxidation number? That is a number given to elements in the free and combined states, okay, as far as our determined set of rules is concerned, okay. Are we together? most of the time is the charge an atom on an atom when the atom donate or receive an electron. Are we together? For example, the group 1 element, they are able to give 1 electron. So, and when they ionize completely by losing 1 electron, so they become positively charged. So they carry 1 charge. So that means they carry +1. Are we together? So there's loss of 1 electron. They've donated 1 electron, and that means they will carry +1. So that +1 becomes their oxidation number. Okay. For an atom, the oxidation number of an atom is 0. Are we okay? Good. So now, reduction in terms of oxidation number will be what? A decrease in oxidation number. That is reduction. Are we together? Good. So let's move on. I'm sure the class is getting interesting. So oxidation, addition of oxygen. So let's consider burning of magnesium. That is combustion now. You can see that when we have added oxygen to magnesium, so that is oxidation. Okay, so if you see here to here, so we can say that is what? Oxidation. So here is now having oxygen. Are we together? And there is reduction. Okay, here to here is what? Reduction. Are we together? But what is important is what I want us to understand is we've added oxygen to magnesium. Okay, so addition of oxygen is known as oxidation. Okay, good. And the loss of electron, in terms of loss of electron, we say oxidation is loss of electron. Yes or yes? Good. So magnesium in this, okay, so that's why you know where, so because you are going to be coming across something like this and you came across something like this under electrolysis. Yes or yes? Okay, good. So loss of electron, this is a magnesium atom. Okay, now magnesium belongs to group 2, so it's going to donate 2 electrons, and donating 2 electrons means losing 2. Okay, so and because of that there is loss of electron, and that means this is an oxidation. Are we together? So an atom is losing 2 to become magnesium, to carry positively charged, to carry positive charge ions. Are we together? Good. So this is an oxidation, loss of electron. Okay, good. So and that is from magnesium to magnesium ion. Okay, so let's talk about reduction. Okay, if I'm to talk about in terms of oxidation number for this, you can see that here the oxidation number is 0. Okay, and here the oxidation number is what? Is +2. So there's increase in oxidation number, and that also validates what an oxidation is all about. So reduction quickly. Okay, now removal of oxygen, that is reduction. Okay, so there's reduction of iron 2 oxide. This is iron 2 oxide, and you can see that here. Okay, to this, that is oxidation. So oxygen has been separated, has been removed from what? Iron 2. So, and that means that is reduction. So removal of oxygen. Okay, good. And gains of electrons. Gains of what? Electrons. So iron 3 are converted into iron atom. Okay, remember what I stated under that electrolysis when I told you that copper 2 is reduced to copper atom. So, and that is done when there is what? Gains of electron. Okay, and that happens when there is what? Gains of electron, and that is reduction. Okay, that is reduction. So example Okay, thermite is used to weld pieces of metals, especially when the source of electricity is not there. So we use it as source of what? Electricity. Okay, and that's principally the process involved is oxidation reduction reaction. So in this equation, for that thermite reactions, so we want to identify the elements being oxidized and those ones that are being reduced. So let's follow the class. Okay, as we have it now, so we have two ways we are going to identify that, and that is by oxygen and by the electrons. Okay, so this is more balanced now, so let's go. From here we can see that okay, from here to this. Okay, so here is just aluminum. Oxygen has been added. What that means is what? That is oxidation. Okay, so the process is what? Oxidation. The process is what? Oxidation. So oxidation has taken place, and that means aluminum has been oxidized. Are we together? So the element or substance that is being oxidized becomes a reducing agent. Let's take note of that. So element or substance that is oxidized becomes the reducing agent. Are we together? Now, here there is what? Removal of oxygen. Okay, removal of what? Oxygen. So what that means is that removal of oxygen is what? Is reduction. Okay, removal of oxygen is what? Reduction. Good. Reduction. So reduction, and meaning that here, okay, iron 2 has been what? Reduced. Is that not? Good. Aha. So and the one that is being reduced, where we have reduction, then we are going to have oxidizing agents. Are we together? So the one that is being reduced becomes the oxidizing agent. The one that is being oxidized becomes the reducing agent. So as clear as what I've stated earlier, so aluminum is oxidized because it gains oxygen, remember, and iron is being reduced because it's losing oxygen. Are we together? As quick as possible. So based on their electron also, so we see that there's loss of 3 electrons for aluminum to become aluminum metals, and that is an atom. Okay, and loss of electron is oxidation. Okay, and for the next one, gain of electrons, that is what? Reduction. So the one that is being reduced. Are we together? And you can see that the oxidation number changed from 3, okay, here to 0 to an atom. Okay, are we together? So that means oxidizing agent is the one that is being reduced. Reducing agent is the one that is being oxidized. Clearly? And thank you for following the class once again. So common examples of oxidizing and reducing agents. So let's start with oxidizing agents. Examples, we have antiseptics and your disinfectant, you know, the one used to kill microorganisms and antibacterials. Okay, good. So these are examples of oxidizing agents. Oh, very good. You can have it there, the antiseptics. I'm sure you have it at home. Are we together? Good. Oxygen is a common agent for oxidizing. Okay, and the hydrogen peroxide is also an oxidizing agent. We have benzoyl peroxide, oxidizing agent, and iodine is an oxidizing agent. Okay, then chlorine is also a very powerful oxidizing agent. Sodium hypochlorite is an example of oxidizing agent. So we move to reducing agent, and common examples, very important. Of course, although they are less available, less common in our household, okay, they are much more available in the industrial environment. Okay, so hydrogen, especially when we talk about herbal process, Haber process, you know powerfully that hydrogen is a good reducing agent. Okay. Also, coke or carbon. You understand? So in the class ahead, we are going to talk about coke. Okay, or carbon. Coke is an amorphous of carbon. Are we together? Good. Then is a powerful reducing agent. Okay. In nitrogen fixation, so reducing agent, and this is just examples, pictorial view of coke related substance. Good. Okay, so we are moving to more examples. How do we identify the oxidizing and reducing agent? Okay, so we have some few examples. Example number 1 and example number 2. So let's quickly explain how do we determine which of them is going to be reducing agent, which of them will be oxidizing agent, based on what we have been able to understand so far. Okay, remember I told us we can do that by getting their first their addition of oxygen, removal of oxygen. Okay, you check it. Okay, if there is no oxygen, what do you check? You check the oxidation number. Okay, is there increment, or is the oxidation number decrease? Is it decreasing? And you can use it to dictate or determine what a reducing agent is all about and what oxidizing agent is all about. Are we together? So let's quickly solve this problem or problems. I mean, there are two. Good. So the first one is copper. Okay, now checking it, there's nothing like oxygen, so we are not going to look in terms of oxygen. So the next that comes to our mind is in terms of increment or decrease in oxidation number. Okay, now let's check this guy and this. Okay, go. So the oxidation number of this is 2. That's why we say it's copper 2, right? Good. And here is copper, and that is metal. So the oxidation number here is 0. Are we together? This is 2. Okay, 2 plus. Are we okay? So if 2 plus, that means there is a reduction. Are we together? So this is a reduction. Are we together? Okay? Meaning that copper 2 has been reduced. Are we okay? So, and because it has been reduced, so this becomes the oxidizing agent. Okay? That's why we said oxidizing agent is one that is being what? Reduced. Reducing agent is one that is being oxidized. Are we together? So, of course, without much explanation, you know that this becomes a reducing agent, right? Good. Why? Okay, so as you are smart as a student, so you should be able to know that the oxidation number of zinc here is what? 0, and here is what? Plus 2. So there's increment in the oxidation number, and that means it's an oxidation. Are we together? So meaning that zinc is being oxidized, and the one that is being oxidized becomes the reducing agent. Are we clear? Very good. You have to understand this because we will still come across it when we talk about balancing chemical, redox reaction. So copper 2 gains electrons and is being reduced, therefore is an oxidizing agent, and then zinc loses electron because it's being oxidized, okay, and therefore is a reducing agent. Very good. So let's consider the next example. Okay, so where we have magnesium undergoing combustion, okay, addition of oxygen. So of course, without wasting our time here, okay, and let's label this on A, okay, and we label this also B, okay, we label it what? B. Good. So there is here we talk about oxygen, right? Yes, addition of oxygen, okay, and there's a reduction in oxygen, in the numbers of electrons of oxygen. So the first one, since we have reduction, okay, or let's talk about B first. So there is an addition of oxygen, and that means the reaction is what? Is oxidation. So meaning that magnesium is being oxidized, and that means magnesium is what? Re, is a reducing agent. Okay, good. Is a what? Reducing agent. There's loss of electrons. Okay, oxidation, and then there is reduction. Okay, there's what? Reduction, and where we have that means we have this becomes our oxidizing what? Agent. Very good. Oxidizing what? Agent. So oxygen gains electrons and loses an oxygen atom. So it's being reduced, and therefore is our oxidizing agent. And magnesium loses electrons and gains oxygen. Because of that, is our reducing agent.